cosine A minus 2 sine A cosine A over cosine square A minus sine square A plus sine A minus 1. Ooh, ugly. Okay, let's see. What can we do on the top first? We can factor cosine A out, right? So it becomes 1 minus 2 sine A. The reason we want to do factoring because that's the only way we can do canceling on the numerator and denominator. Okay, so try your best to fully factor whatever the numerator or denominator. Now, for the denominator, honestly, I look at that, I get a bit confused until I realize I can actually combine these two. This one here, this guy minus this guy. What will that be? Sine squared A plus cosine squared A equals to 1. So sine squared A equals to 1 minus cosine squared A. Is it right? So what is cosine squared A minus 1? Negative sine squared A. Now, that's what I will do there. That will give me negative sine squared A minus sine squared A plus sine A. I will combine like terms at the bottom. I mean, yeah, at the bottom. On the top, I will leave it like that. Try not to skip steps though. Okay, try not to skip steps. You don't want to lose track of what you do. When it comes to proofing later on, I assume that you took trigonometry somewhere, and in every trigonometry class I taught, there must be some proofing. I know some teachers actually avoid proofing, but you're supposed to do proofing. Okay, now when it comes to proof, I noticed that those students who cannot do proofing are those students who usually skip steps. This is the way they think. This is the way I think. I can do it mentally. So I can skip step. Okay, now what happens if I can't not do it mentally? So I don't skip step, right? That's the logic, right? Okay, but if you don't skip step, what do you do? I will write it down. Think about this logic. If I can do it mentally, then I have the right to skip the step. If I cannot do it mentally, then I will write it down. Sounds so innocent, right? Okay, but let me tell you what usually happens in the test. Okay, those that you think, oh, I can do it mentally, I will just skip the step. Okay, assume that you are fine. What if you cannot do it mentally? Will you write it down? The problem is the reason you cannot do it mentally is because you don't even know what to write. If you cannot write it in your mind, what makes you think you can write it down on paper? You cannot even imagine that. Right? Okay? So even though this argument seems to be innocent, but what end up happening in my test, and in a lot of tests I already seen from those teachers who like to give proofing, okay, and those students who say, you know what, Thomas, I just do it mentally, you will see when it comes to proofing, they tend to leave it blank. The reason is, if they can do it mentally, they skip steps, they don't write anything until they cannot do it mentally. But when they cannot do it mentally, the reason that they cannot do it mentally because they can't even write it in their mind. So they have nothing to write down. Either way, they don't write anything down in this case, and they cannot write anything down in this case. Okay? That's why they leave it blank, because if they know what to write, they don't write it down. If they don't know what to write, they don't know what to write. Boom. Okay, so I hope you see my reasoning. I want you to write each steps. Okay, I don't write. That's what I want you to do. Trust me. However much you guys say, Thomas, you're too strict. Thomas, I don't like you because you're kind of too picky. I have those kind of teachers too before. Okay, not that I want you to pay back what the crime that my previous teacher did. No. I have today, I can be so good in my math, at least at this level right now, is because I have those teachers in the past who prepared me not to be like this. They did very, very good job in me. That's why I want to do the same thing to you, okay? But Thomas, I don't do math only, I have other classes. Yeah, me too. What makes you think I have my master's? Right? You think I take less classes to get my master's than you? To get your associate? No, right? I have done more. And the reason I can go this far is because there are people in my past who prepared me well. And I want to be that kind of person to you. Okay? I don't want to be the teacher who just let you pass, but then you forget that teacher's name. You just remember that that teacher don't prepare you well. I don't want to be that kind of teacher. Now, go on further. Oh, at the bottom, you see that I can factor sine A, huh? Don't you think so? I can factor out sine A, and I get -2 sine A plus 1. And notice that this guy here is the same guy with this. Is it right? So I can cancel that and get cosine A over sine A, which will be cotangent A. So
The book
you
said
see,
leave it in terms of cosine and sine.
repeat again.
The book said leave it in terms of cosine and sine.
Oh, okay, okay. Yeah, if you leave it in terms of cosine and sine, just then you can stop here. Then you can stop. Okay. Yeah, I happen to see that, you know what, that happens to be a special ratio. Then I go on call that cotangent. How about number 44? You do that. Number 44. Simplify cotangent theta plus 1 minus 2 cosine squared theta over sine theta cosine theta. Now, cotangent is cosine theta over sine theta. So I help you with the first step. I think that one is so obvious. What do you think the next step?
Multiply
By what?
by LCD.
Huh? That's not an equation, though. You cannot do that.
It's a plus sign in between the two.
But this is not equation. This is expression.
I'm talking about combining the fractions into one.
Yeah. Then no. We don't say that we multiply by the LCD. We find the LCD.
Oh, we find the
Okay.
LCD.
Yeah. We find the LCD. LCD is sine theta cosine theta, right?
Yeah.
So on the first fraction, we multiply the top and the bottom by cosine theta. Multiply by cosine theta here, by cosine theta here. Now, notice that they have LCD already, such that I can put them under one fraction, right? Sine theta, cosine theta. The first term is cosine squared theta plus 1 minus 2 cosine squared theta. Then what next?
Then you I think you can turn the one into sine. I don't know.
I think, yes, I agree with you. You can do it that way. But in my opinion, it's simpler to just combine like terms first. Right? We can combine like terms. 1 minus cosine squared theta. Right? And then, oh, the top one is Pythagorean identity. That's sine squared theta over sine squared, sine theta cosine theta. Cancel one of the sine. We get sine theta over cosine theta. Okay. Now, they say leave it in sine cosine, then that's fine. And this is equals to tangent theta if you want to go on. Now, let me ask you to do one question and then I move to the next section 6.4. Let me ask you to do number 52. Simplify as much as you can. Cosine 90 degrees minus A over cosecant A plus sine 90 degrees minus A over secant A. You should be able to do that in 3 or 4 minutes. Maybe one more, why not? Number 56. Number 56. Cotangent beta over cotangent beta plus 1 over cotangent beta plus 1 big over cotangent beta minus 1 over cotangent beta minus 1. That should take you also around 3 or 4 minutes. Together with your break, we come back at 5:50. So 40. Okay, let's come back at 5:50. This is actually just negative of 2 cotangent beta. Why keep it random? This, I think this is simply simple enough, but if they want us to write it in terms of sine and cosine, then that will be negative 2 cosine beta over sine beta. Let me do LCD right away. Sine beta over sine, that will be negative 2 cosine beta minus sine beta over sine beta. I think that's the simplest I can go. I prefer this one. This is the one I prefer. If they don't tell me where to stop, I will stop here. Okay, but because they say that make it into cosine and sine, then I stop there. Okay, now your suggested homework from this 6.2 will be 6.2 suggested homework starts from number 1 to number 17. Okay. But just do part B. Just do part B. You don't need to do part A. And then number 19 to number 29, preferably method 2. Okay, and then number 35 to number 55, and every other odd. Then the rest of the odd. So you do every other odd first. If you feel that you're comfortable, go ahead with the 6.4. Okay, but if you don't feel like you are strong enough, then go on, do more. Okay, now the reason I say that you may be able to, you can do every other odd here. You can do every other odd here first, because you will see that again anyway in 6.5. Okay, that's the reason. You will see that again anyway in 6.5. Now, let's go on to 6.4. We did 6.3 last time. Yeah, 6.4 is on 6.4 is on trig functions, and they call that unit circle approach. Now, the way we learn it in 6.1, we define those trig functions using a right triangle. And you see that we can apply so many things from this right triangle. Okay, we can compute the values, we can have application, we can have simplifying expression like what we did earlier. But this right triangle approach has a weakness. Right triangle approach can deal with only acute angles. The theta we use only for acute angle. Well, because you start from a right triangle. If you have a right triangle, then the other two angles has to be acute. Okay, because the sum is 180, right? if the sum of the interior angle is 180 degrees and one of them already 90 degrees, then the sum of the other two has to be 90. Cannot be more than 90. Okay? Now, that's the weakness of the right triangle approach. It doesn't mean it's wrong. No, it's not wrong. It's just weak because we can only apply those ideas in a right triangle. Now, suppose I superimpose this triangle here. If I superimpose this triangle here into a circle. So I go on a bit further. Okay, if I superimpose this idea of right triangle into a circle, okay, and then I pick a point on the circle. Let's say I pick a point on the circle. I call this point P, whose coordinate x, y. Now then, the angle in standard position. So I think I have to define it. I wonder if I defined it before. Not here, huh? Okay. Angle theta is in standard position if the initial side is positive x-axis, second, the vertex is origin, and the third, the terminal side it counterclockwise to the terminal side. Sorry, the direction counterclockwise to the terminal side. Okay, so that angle theta is from positive x-axis going here. Okay, now I said earlier I superimpose that right triangle into this circle, which implies what I'm trying to say is this. Now I have this right triangle here. I have this right triangle here. Okay, I purposely pick my coordinate P in the first quadrant. Okay, and notice that the length here will be what?
X.
That's x, that's right. And the length here will be
Y.
y. Now we will then not really redefine, but we extend the definition of sine. We extend the definition of sine theta now to be opposite y over the hypotenuse r. This is the r here, okay, which is the hypotenuse of x and y. Okay, and cosine theta equals to x over r. Tangent theta will be y over x. Okay, so we redefine it And even though it seems like Thomas, it seems to be just the same thing that we have last time. It is true. If my theta, my P is in quadrant 1, then we have exactly the same definition as before. But notice that this definition actually can carry into other quadrants. Now, my P can be in quadrant 2, maybe in quadrant 3, maybe in quadrant 4, right? Okay, so suppose for example, I say the following. For example, find the trig values of theta in standard position. Actually, whatever theta given to us here, unless said otherwise, it will be it is in sense of standard position. So when we say theta is 30 degrees, we don't need to say anymore it is counterclockwise or clockwise, from positive x-axis, from negative x-axis, or from y-axis. No need. Once I say 30 degrees, it means that thing. It is in standard position, unless I say it another way, okay? But if I don't say anything, I just tell you the angle, then it must be in standard position, okay? That's by convention. Now find the trig values of theta in standard position. Correspond to let's say P negative 5 4. Negative 5 12. So the coordinate is in quadrant 2, negative 5, comma 12. Let's say that's the picture. And the angle is like this from positive x-axis. That's theta, right? Okay, now the coordinate is here. This is negative 5, comma 12. By the way, what's the radius?
One. What's the radius?
The radius.
13.
What is the radius?
The radius is 13.
Yeah, the radius is 13. That's right. Give me a second. I need to fix it. Yeah, the radius is 13. The numbers I use happens to be a triplet, right? Okay. Now then, so the radius is 13. Then actually we can already find what is sine theta. Sine theta will be the y over r, right? Cosine theta is dx over r, and tangent theta will be y over x. Okay. But our focus will not be in here, even though it's already quite useful. But our focus will actually go to what we call unit circle. Unit circle. Let me say it again. We will approach this using unit circle, and all of a sudden, we have a much better definition for sine, cosine, tangent thingy. Suppose I have a unit circle. So the length here is 1. The radius is 1. So the coordinates here will be what? What is the coordinate here? If the radius is 1. 1, 0, right? And this is 0, 1. Are you with me?
Yes.
Now, suppose I draw a line from the origin to one of the point on the circle. Okay, just like before, this coordinate is coordinate xy, right? Okay. However, this time the radius is 1. Now, suppose this is angle theta. Now, according to the theory we have last time, what is sine theta?
So, pumasok si Badit, nagmukha na ang niyaya ni Badit.
What is sine theta? Sine theta will be y over 1, right? Because the radius is 1. So sine theta will be y over 1 or simply y. And cosine theta is x over 1, which is simply x. So if the radius is 1, the x component of that, the x component of this coordinate is the same to cosine theta. The y component will be the same to sine theta. Okay. Now, just I try to do a little illustration at how we will use this. Suppose I have a unit circle. Let me draw it small enough here. Okay, and then I have angle 30 degrees, or make it 60 degrees. Why not? So I have angle 60 degrees here. This angle here is 60 degrees. Then, according to that theory, we know what's the coordinate here right away. If you know the angle, you know the coordinate. If you know the coordinate, you know the angle. Okay? Actually, the emphasis will be if you know the angle, you will know the coordinate. Okay, according to the theory we have, the coordinate here will be, the x component will be cosine 60 degrees. The y component will be sine 60 degrees. Okay, if the radius is 1. Does it make sense? That's 1/2 radical 3 over 2. Now, from here I go for blast. I want you to tell me what is the angle associated to this side here. What is the angle associated to this?
X over 1.
The angle.
Cosine theta over 1.
Angle.
Theta.
What is the theta?
You didn't say.
Well, look at the picture.
Which picture? The first one or the second
This one.
one?
Radical 3?
No. What is the angle there? Okay. Maybe I changed the question then. Okay. What is the angle associated to this terminal side?
90 degrees.
That's 90 degrees. That's right. Okay. Now, then going back, what is, oops, what did I do?
Oh, so 30?
What is the angle associated to this side?
180.
Zero.
That's 0 degree.
Oh,
That's 0
okay.
degree, right? Okay, that's 0 degree. So So sine 0 degree and cosine 0 degree equals to what? Now we know, if we know the central angle, in this case is 0 degree, then the coordinate associated to that will tell us the cosine and the sine. Okay, notice that the cosine is always the x, the sine is always the y. Okay, so if we know the coordinate here is 1, 0, then that one here is for the cosine. Okay, and the 0 here is for the sine. Cosine 0 degree is 1, sine 0 degree is 0. Now notice that however innocent these two values look like, we cannot find the value of sine 0 degrees and cosine 0 degrees using a triangle. No. We cannot use a triangle. We cannot use a right triangle. Why? Because in a right triangle, all the angle has to be positive. Cannot be 0. Okay? That's why for us to find the value of sine 0 and cosine 0 degrees, we need to use this unit triangle approach. But the idea is actually quite simple. Okay? The x component of the coordinate is the cosine of that angle. The y component of that coordinate is the sine of that angle. Now, using the same idea, then tell me what is sine 90 degrees. Then you see, oh, you know what? Which coordinate actually correspond to that 90 degree? And you say, oh, it's this coordinate here, right? Yeah, this coordinate 0, 1 give us angle 90 degrees, right? Okay. Now, because of that, then what is sine 90 degrees?
1.
Sine 90 degrees is 1. Okay. So here's the thing. I know a lot of you already memorized sine 90 degrees equals to 1. But do you know how we get that?
Yes.
Right? Okay. You may know how to get that. I mean, you may memorize it, but if you don't know how to get it, then it's easy for me to just ask you, it's like, okay, what is cosine 180 degrees? And you suddenly don't know what to do. Okay. The way we get sine cosine 0 degree is the same to the way we get sine cosine 90 degrees, the same to the way we get sine cosine 180 degrees, sine cosine 270 degrees. Okay. Now, how about sine 180 degrees? Oh, well, that's y component. That's the y component of the coordinate. That's the y component of the coordinate. Okay, that form 180 degrees. Correspond to 180 degrees. You see what I mean? Now, what is the coordinate here? That's -1, 0. Okay, now then, what is sine 180? That's the y component of that coordinate. How about cosine 180 degrees? That's the x component of that coordinate. Now then, can you tell me what is sine 270 degrees and cosine 270 degrees? For 270 degrees, the coordinate associated to that angle on the unit circle is here. And that coordinate is 0, -1. So the sine value of 270 degrees is -1. Cosine value is 0. Okay, so at this point, let's take a look on what we have known. The special angles, 30 degrees, 45 degrees, 60 degrees, we learned it last time, for sine, cosine, and tangent. Okay, we already know this last time. This is from Tuesday. Okay, now just now we get the value of sine, cosine, and therefore tangent for 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And we get that from unit circle. Okay, let me fill it up. This is 1/2 radical 2 over 2, radical 3 over 2, radical 3 over 2, radical 2 over 2, 1/2. This is 1 over radical 3, which is 3. This is 1, this is radical 2. This is 0, this is 1, this is 0, this is 1, 0. Undefined. Okay, this is 0, -1. So this is 0. And this is -1, 0. Undefined. Okay, now next. From this unit circle approach, we also realize something very important, which you already know in the past. That therefore we will have that in the first quadrant, all sine, which is the y, cosine, which is the x, and tangent, which is the quotient, are positive. Now, if you have an angle in quadrant 2, just imagine if you pick a point in quadrant 2, now the x will be negative, the y will be positive, right? Now it means the sine will be positive, yet the cosine will be negative. Okay, because sine is positive but cosine negative, then the tangent will be negative. Okay, so in quadrant 2, only sine positive. In quadrant 3, both the x and the y are negative. Therefore, both sine and cosine negative. And therefore, the quotient tangent is the one positive. Okay, of those three sine, cosine, tangent, in quadrant 2 only sine positive, in quadrant 3 only tangent positive, and in quadrant 4 only cosine positive. And we can see it from here. Coordinate in quadrant 4 will be positive, negative, which implies the cosine theta is positive, the sine is negative, and therefore tangent also negative. Okay, cosine is positive. Okay, let me color them. All positive, sine positive in quadrant 2, tangent positive in quadrant 3, cosine positive in quadrant 4. Now, I want to go on. Introducing to you a new terminology, which is not really new if you really did your trigonometry well. A new terminology called reference angle. Definition: the reference angle of angle theta denoted by theta hat. Okay, that's my notation. Apparently our textbook does not use that notation. I use that notation. Is the acute angle between terminal site x-axis with vertex and origin, and an x-axis with vertex origin. With vertex 0, 0. Now, two keywords here. One, that the angle for reference angle has to be an acute angle. Second, it's the angle between terminal site and x-axis, okay? Not necessarily positive x-axis, as opposed to the standard position. For standard position, the vertex is origin, it has to be positive x-axis, and it has to be counterclockwise, okay? But reference angle, no. As long as it is an acute angle to any x-axis, positive or negative x-axis. Now, let's see what's that. Suppose I have an angle in the first quadrant. Suppose I have an angle in first quadrant. Okay, then you will see the reference angle of this angle is the same, are the same. Okay, now on the other hand, suppose I have an angle in quadrant 2. Suppose I have an angle in quadrant 2. Let me call that alpha, angle alpha. Okay, alpha is in standard position. Now, what is the reference angle? The reference angle is this angle here. That's the reference angle. We call that alpha hat. Notice that alpha hat is 180 degrees minus alpha. Okay, or the sum has to be 180 degrees. Now, what happens if the angle is in quadrant 3? Let's call this angle beta. Let's call that angle beta. Then beta hat will be here. This is beta hat. Okay, the angle between the terminal site the angle between the terminal side and x-axis. Okay. Now notice that the reference angle here is basically 180. Is basically 180 degrees. The angle, the total angle from positive x-axis to that terminal side, okay, is basically 180 degrees plus the reference angle. In other words, the reference angle is equal to the angle in standard position minus 180 degrees. Finally, what happens if I have an angle in quadrant 4? Let me call that angle alpha. I mean angle gamma. I need to make it very big. This is angle gamma. Ooh, so big. This is angle gamma. Boom. Then the reference angle will be this guy here, gamma head. Now this gamma head, the reference angle of angle gamma is 360 degrees minus gamma. Now you will see for us to compute the special angles in quadrant 2 and 3 on 4 and other angles later on relies heavily on this reference angle approach together with unit circle. Okay, now what are you trying to say, Thomas? It is the following. Let's start taking a look at this situation here. Let's say I have a unit circle. Let's say I have a unit circle. This is 1, 0. This is 0, 1, right? Okay. Now, and then let me pick a coordinate. Let me pick a coordinate in quadrant 1. Let me pick a coordinate in quadrant 1. Let me pick this guy here. Okay. And let's say the coordinate here is x, y. Let's say the coordinate there is x, y. Suppose this is angle theta. Suppose that's angle theta. Let me use another color. Let's say this is angle theta here. So can you tell me what is this coordinate?
What's the question? Don't you have it in red already?
Huh?
Isn't the coordinate xy?
Yeah, the coordinate is xy, but in terms of theta.
Oh,
Cosine
cosine
theta, sine theta. Is it right?
Yeah.
Okay. Now, here's the thing. Consider the following rectangle. Consider the following rectangle. Now, can you tell me what is the coordinate here in terms of xy?
It's going to be negative cosine theta.
In terms of xy, it will be negative x comma y.
Oh.
Right? The same y to that one, right? The same y to that one, but opposite x. Now, how about the coordinate here? In terms of xy.
Negative x, negative y.
Negative x, negative y. And the coordinate here will be x comma negative y. Is it right? Now, but the thing is, each of those coordinates, if each of those coordinates actually have the same reference angle. Each of that has the same reference angle. This is theta, this is also theta, this is also theta. Such that we can say the following. Notice that if angle alpha and angle beta, they may be different angles, have the reference angle the same reference angle, then the trig function of alpha is equal to the trig function of angle beta, and they differ only on the plus minus. So this is what I want to say. To kind of like clarify that example, that theory there. Suppose I have sine 50 degrees. Now that's in quadrant 1, right? Okay. Now the value of this sine 50 degrees will be the same or opposite to sine of any angle whose reference is 50 degrees. For example, 230 degrees. They must have the same value or exactly opposite value. Okay, because if we look back here, suppose this is 50 degrees and 230 degrees has this reference angle 50 degrees also, right? Okay, then the sine of 50 degrees, in this case is y, okay, will be equal to or opposite to sine 230 degrees. So whatever the value there will be the same or opposite to the value here, 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 as long as they have the same reference angle. Okay, now of course, since we know that since sine is negative in quadrant 3, then we can go further saying that sine 50 degrees is actually the opposite of sine 230 degrees. Now we will use this idea to answer a lot of questions we can find the value of trig functions of special angles in quadrant 2, 3, 4. Suppose, for example, call this example 2. You see the example 2? Yeah, that's example 2. Suppose, for example, I want to find out what is sine 150 degrees. So I ask myself first, 150 degrees is in which quadrant?
Second quadrant.
Quadrant 2. Okay. Now, what is the reference angle of 150 degrees?
30.
30 degrees. Now, so sine 150 degrees will be, because it's in quadrant 2, that will be positive, right? That will be positive. We usually don't write it if it is positive, okay? Of sine of the reference angle. So notice that I suddenly go to quadrant 1 and sine 30 degrees is 1/2. How about, for example, cosine 240 degrees? Then we ask ourselves, oh, you know what? 240 degrees is in which quadrant?
Third.
See, that's the third quadrant. And the reference angle is
60.
60. Okay, 60 degrees, 240 degrees minus 180 degrees, that's 60 degrees. Okay, now then, in quadrant 3, cosine positive or negative?
Negative.
That's negative. Because it's in quadrant 3, cosine is negative. Okay, the same trig function, okay, the reference angle is 60 degrees. And therefore, this is equals to negative 1/2 again. How about tangent 315 degrees? Which quadrant?
Fourth quadrant.
That's in quadrant 4. In quadrant 4, tangent is positive or negative?
Negative.
Negative. Now then, what is the reference angle?
45 degrees.
And we get it from 360 minus 315 degrees, that's 45 degrees. So this is equal to negative tangent 45 degrees, that's negative 1. Okay, now we are ready to prove, basic identity 4. Proof for B4, that is sine negative theta equals to negative sine theta. Okay, cosine negative theta is just cosine theta. Consequently, tangent negative theta will be negative tangent theta. Now, what's the proof? Here's the proof. Let's make it larger. The proof is actually by graphing though. I proved that by graph. Now suppose I have a negative angle. Okay, maybe here. Let's say I have a negative angle. Negative angle, basically, you start from positive x-axis, but you go opposite direction. Instead of counterclockwise, you go clockwise. Okay, so this is negative theta here. Okay, now because that's negative theta, what is the coordinate here? The coordinate associated to the angle must be cosine negative theta sine negative theta. Are you with me? Now compare that with the angle but positive. This one. This is angle theta. The coordinate will be cosine theta sine theta. Now notice that their x component are the same. Their x component are the same. Okay, I don't want to use that. The x components are the same. Right? Do you see that? Okay. So from there we see that cosine negative theta equals to cosine theta. Now, on the other hand, the sine are opposites though. You see that the y value for the coordinate associated to negative theta is the same length here. They are the same length, but opposite. So we get sine negative theta is equals to the opposite of sine theta. That's how we prove it. So I prove it by pictures. Now, furthermore, then we can do more problems now. Let's say, for example, example 3. Suppose I have, let's say, cosine negative 120 degrees. Cosine negative is cosine positive. I use B4, and that's cosine 120 degrees. Then I ask myself, 120 degrees is in which quadrant?
Second.
The second quadrant. Okay, so we need to know what quadrant it is in to know if it is positive or negative, right? And then what's the reference angle?
60.
60 degrees. So negative cosine 60 degrees, that's negative 1/2. Okay, now how about if I ask, oh, you know what is cotangent of negative 300 degrees? Oh, Thomas, you never talk about cotangent of negative angle. Yeah, but I talk about cotangent is the reciprocal of tangent, right? Okay, so this is 1 over tangent negative 300 degrees. And tangent negative is negative tangent. Okay? So the one here, I use B1. Here I use B1. Here I use B4. And then from there I proceed as usual. 300 degrees is in which quadrant?
He's in the third quadrant.
Quadrant 4.
Oh,
It's more than 270.
sorry.
Okay, now tangent in quadrant 4 will be negative. Okay, and the reference angle will be 60 degrees. Okay, so that will be negative tangent 60 degrees. Now I have two negatives that will cancel each other. Okay, so I will get 1 over tangent 60 degrees is radical 3. Rationalize. Good. Now you try this. How about if I have, for example, secant negative 210 degrees. Do the reciprocal first, and then take the negative angle, and then will the quadrant thing. I give you maybe 2 or 3 minutes. This is 1 over cosine negative 210 degrees. Cosine negative is cosine positive. Okay, that's how far I go. Then from there, I start the routine. Okay, 210 degrees is in which quadrant? That's quadrant 3. And in quadrant 3, cosine is negative. Negative cosine of what is the reference angle? Reference angle 30 degrees. So this is 1 over negative radical 3 over 2. That's negative 2 over radical 3. Rationalize the denominator. This is what I get. Okay, so your suggested homework will be, from here, 6.4 will be number 1, then I want you to actually focus on number 41 and on 41 to 47. Okay. Oh, by the way, if it is more than 360 degrees, make it into less than 360 degrees first. Let's say if I need to answer tangent 600 degrees, then I will say, oh, that's equals to coterminal with tangent 240 degrees, right? 600 degrees minus 360 degrees, that's 240 degrees. That's the coterminal. And then from there you go on further. Okay, now that's for this section. 6.5, I still have 10 minutes, so let me go to 6.5. Your test will include 6.5, even though I cannot finish 6.5 today, but the foundation already there though. 6.5. There are two major parts here. The first one is given a trig value of an angle. It doesn't have to be an acute angle anymore. Find the remaining trig value, the remaining trig values of that angle. And second, we will learn to prove proving identities. Now, I will do part A here, and part B, try to watch lecture video if possible. Part B will still be in your test Thursday. So on Tuesday, I will continue on 6.5 on the proving. I will do part A right now. Okay. For example, let cosine theta equals to -2/3, and theta is in quadrant 3. And we want to find the remaining trig values, sine theta, tangent theta, secant theta, cosecant theta. Idea, the first step, we'll find the ratio. We'll find the ratio. In a right triangle. So I will do it this way. Cosine theta hat will be cosine theta hat will be cosine theta is -2/3, right? Okay. Now reference angle must be an acute angle, and the number will be the same. So in other words, cosine theta hat will be the same number with this, but it must be positive. Now then, from there, I construct the right triangle, and that's the reason I actually do the reference angle, because I try to make it an acute angle so that I can put it in a triangle. By Pythagorean identity, I will Pythagorean theorem, I will get this is square root of 5. So from there, I see sine theta hat is radical 5/3. Cosine theta hat is already known. Tangent theta hat is radical 5/2. And of course, from there, I get what is sine theta.
3.
Radical 5/3, but with negative. Why is it negative? Because theta is in quadrant 3. Okay, I get the number from sine of the reference angle. I get the plus minus from the quadrant. Okay, so what is tangent theta? The number must be radical 3/2, the same to tangent of the reference angle. Okay, how about the sine? Is it positive or negative?
Positive.
Positive, because tangent is positive in quadrant 3. Okay, now once you get those two, then we can, from there, then we can go on, using these two, we can go on finding what is, for example, secant theta. Secant theta is the reciprocal of cosine. How about cosecant theta? That's reciprocal of sine. And tangent, cotangent theta will be the reciprocal of cotangent. furthermore, let me do one more problem in the last 3 minutes. Ooh, is it possible, Thomas? Very possible. Example 2. Suppose I say let tangent theta equals to x. X is in quadrant 2. Some side question. Is x positive or negative?
Negative.
Yeah, it's negative. Okay, so x is negative. Okay, x is negative. Now then, what I will do is then I take a look on the reference angle. Once the angle is not an acute angle, do the reference angle. Now tangent theta hat will be negative x, right? Now even though I use negative sign here, but because x is negative, to make it positive, I put another negative. Okay, because x is negative, then negative x is positive. Does it make sense? Now draw the right triangle. Boom. Boom. This is theta hat, right angle, negative x over 1. Okay, so this will be square root of x squared plus 1. Then sine theta hat is negative x over square root of x squared plus 1. By the way, is this positive or negative?
Positive.
That's positive. The denominator with square root is always positive. The numerator, negative x, is positive. That's what we said earlier, right? Okay, so then suppose I want to find, now if I want to find sine theta, sine theta, should that be positive or negative?
Positive.
That's positive, right? But we know this expression is already positive. So I would just keep it that way. This is negative x over square root of x squared plus 1.
Oh, you know what my question is?
Uh-huh. What?
But if x is in the second quadrant, why is it
Theta. If theta in the second quadrant.
Theta. Oh, I'm sorry.
Yeah, if theta in the second quadrant, so I think you're right. I have to actually fix it here. This is theta is in the second quadrant.
Oh, okay.
Okay, yeah, so x will be negative. Now, how about the sine? I mean the cosine. Cosine theta hat will be 1 over square root of x squared plus 1. Now, you know from the expression there, cosine theta hat is positive, but in quadrant 2, it's supposed to be negative, right? So I will change the sign. Cosine theta will be negative 1 over square root of x squared plus 1. Okay, now once I have sine, cosine, and given tangent, we can get the other three, secant, cosecant, cotangent. Okay, that's where I will stop here. Suggested homework for this 6.5a will be number 1 to number 13.
Oh, you know, Professor, I had a quick question.
Uh-huh.
I think it should be negative 1x. The opposite side should be x, and the 1 should be -1 if tangent is in quadrant 2. Remember from how you drew the triangle.
Yeah, but I didn't make it in quadrant 2. I make it in the right triangle.
Confused.
See. Okay, anyway, let me say this first, and then you stay with me, Jeffrey, okay?
Okay.
Now, 6.5b is proofing, and that will still be in your test 3 next Thursday, okay? When you study from my old tests, you will see the proofing part. In fact, if you have a time, take a look on my tests for test 2 and test 3, actually test 1 and test 2, for my Math 241, trigonometry and factors. I taught some trigonometry in the past, so try to take a look on their test 1 and test 2 when it comes to proofing. The way you do proofing is actually similar to, let me show you this, in 6.2, similar to this style here, like left-hand side to right-hand side thingy. Yeah, this style, very similar to this. So anything that you see left-hand side, right-hand side, that's the proofing part, okay? And study, if you want to study ahead, on Tuesday next week, I will go back to the proofing, okay? I will do proofing again. Now that's for today for all of you. And Jeffrey's